Assalamu alaikum, Hamza Karam here. So our task was to simulate or interface a SD card with Zumo robot. Now, what is a Zumo robot? A Zumo robot actually follows a specific path given to it with the help of its six sensors and two motors. Now, where are the six sensors? These are the six sensors that are attached to it. This pin also checks whether it is on the line or it has off the line, and these are the sensors pins that through which we can follow our paths. And these pins 8 and 5. Now 8 and pin 7 are the motor pins that from which we can turn on or off the motor, and here pin 5 and 6 are the PWM pins from which we can control the speed of motor. If we look into the RD microcontroller, here 5 and 6 pins are OC0B and OC0A. Now OCR is basically a register in which we can get specific values to it. On the basis it will just compare this value to the counter, and hence we will get different duty cycles. So these are the two channels of the OCR registers, and we are using timer 0 to control the speed, because this refers to timer 0. Further, there is a Zoom button. Now this button indicates that it's just used whenever we start the simulation. It will indicate the whether if the button is pressed, the Zoom robot will turn on and it will starts following the line. Now this is a buzzer that actually turns on when the zoom has started, and it beeps at the end of the path. If we look closely into the SD card, now SD card is using a SPI protocol. In SPI protocol, there are four pins. The one is chip, MISO, MOSI, clock, and chip select. Chip select refers to which microcontroller wants to communicate with which slave. So basically, this is by keeping it high or low, we can communicate over sensors to microcontroller. MISO to transfer information from master to slave for relatively the data output, because data sometimes is sent from microcontroller to SD card and from SD card to microcontroller, and that one is the clock that actually through which the data is being sent from microcontroller. So this was a simple interface. If you look at the serial monitor, whenever we will write serial print on the code, so that data will appear on the serial monitor. So if we can just run the simulation to show you. Now actually there are two windows. The one is here, the serial monitor, in which as the SD card is initialized, so it is just showing access granted, and we can just start. Now this button, if I will press the button, the Zoom will start following the path. So if the Zoom will turn on, we will hear a beep that will come out of this sensor. Whatever the path the robot is following, the data is being stored on the SD card that we are using here, and basically it will just complete its own path, and the data will be stored. So that's the path. So if I could just now if I just remove the SD card, for instance, there is no SD card in here. If I just remove the now the serial monitor will give me that there is no initialized. As you can see, the SD card will not be initialized, so it has failed, and therefore it cannot open the text file. So if I go into the code, what is happening that we are using a set of libraries. Now these libraries include push button, QTR sensors, Zumo buzzers, Zumo motors, and the header files. Now in the header files, basically we are if we look in the reflected sensors, here we have introduced a header file for sensors, and we have initialized our sensors in this line. So pin 4, 3, and 11. And in Zumo motors, we have the made a library for to control the motors different speeds. Buzzers for the buzzers, we have initialized different nodes for our buzzers. And QTR sensors, same header file that we have just seen. It just calibrates the sensor according to this recon requirement. Push button dot edge header file initialize Zumo button 12, and we have also initialize different states. Now in the we have initialized states and all the different aspects of the button, because we work here using switch case statements, and in switch case statements we initialize different states of the button. So if the state is rising, the state is changed, the pin will be high. If the state is falling, the pin will be low, and vice and like that. In Sumo Motors BP code, we have initialized the PWM pins of the motor that will control the speed of the motor, and the left and right motor pins um that will turn on and turn off the motors respectively. Now these are the we have set conditions to the for our codes, and we are just initializing our motors, giving its output. In timer 0 we have selected our mode, for example fast PWM or whatever we want to. Sorry, it is phase correct PWM mode we have selected. And then we have just selected a prescaler using these bits, that is 20 kilohertz, they written here, and ICR 0. And if further we have just given in the value of OCR 0. Now is OCR 0 speed, whenever the timer and counter value will reach the OCR value, it will just create a different duty cycles, and hence we will control our motor speeds. So this was the code for our motors, and buzzers, same respectively buzzers for our, we have wrote in the code. And in push button CPP we have initialized different states, and that states we are using as I told earlier, because in this Zumo buzzer we actually simulate the buzzer using switch case statements, or most probably in concept of state machines. So in when the state is rising or state is falling, the pins will be high or low respectively and different. So now into the main code. Now these are the sets of header file and source file that we'll be using in our main codes. So we have already included the library that we just mentioned here, and st.h and spi.h. Now spi.h we have included because our SD card uses SPI card protocol, and for that we have to initialize the library of SPI.h. SD.h we have included because whenever we have to initialize our we have to open the file for the respective card, we have to close the file, so we need a file that can do it. So that will do the work. SD cards file, we have actually created a file. Now this is a file where all the data will be stored. We will in which the file is a file in which all the paths will be stored in it. Now chip select pin, it represents the chip select pin of basically this one, that will be high or low respectively, and we can uh, send the information from microcontroller to SD card. Okay, so if we now here is a threshold voltage, and it decides whether the sensor is over a black line. This one is this will be one when is over the line, and zero otherwise. Now the turn speed, it must be positive, so the turn speed it rotates in, it turns in the right direction. Similarly for the both motors, turn speed and simple speed, straight speed. Now it defines the thickness of the line, so I have chosen 0.75 inches. Now the important factor is Z units. What are the used Z units? Basically all the readings that were given to motor speed or something like that. If I can just show you, here we have turning the motor speed 1 or motor speed. If I can just here all the turn speed or whatever that we have given the digits, something like 200, 300. That will be first of all converted into Z units. Now Z units is actually the it is actually converted into inches whatever the inches we have covering, we convert it to Z units. This is the formula for that, and this value actually was found using a 17:1 horsepower motors with batteries. Okay, so it is the same as the upper condition, because when the Zomo reaches the end of the segment, it needs to find out three things. So these three things are whether it has to reach the finish line, or if there is a straight segment, or which segment to take. For that condition, we have just initialized our this condition that will check. Then now we have also initialized Zoomer buzzer, Zoomer reflector sensor, Zoomer motors, push button that we have just created there. Header files we have just initialized. Now we are using 12, so we have placed its argument of 12. This is the array for to store our paths, and pathnet we have initialized at 0. Invite setup, basically simply we will first of all print zoomer test, and now this condition will check that if not st present of chip select 10, then it will print st failed, or if it is present, if the sd card is present, so it will print access granted. Then now this we have to do chip select output, because to because if we will if we will not initialize the chip select as output, then we will cannot access the library functions of st, so we cannot open or close the file, so that's why we have to give it high. Now unsigned sensors 6, we have total 6 sensors, so we have just created a file unsigned count last status. So these are the factors that we are creating in order to keep our robot online. The buzzer will play when the robot starts, and this means that our sensors are being initialized that we have created. The motor speed will be set to 0, and the LED will turn on whenever our robot is first, because we saw whenever we press the button, the sensors turn left and right. So for that purpose, our LED will also turn on that. Now after that, I have just created a file that will indicate that the robot is starting, and it will print in its text file that the part starts now, and on a serial print it will print start. Now when the button is being pressed, so it is actually it is waiting for the button, for the response of button, that if the button is not pressed, the robot will not turn on, but if the button is pressed, the robot will start turning on. Now how it will start, basically it will calibrate. Basically we have created a loop, so it will basically 4 times turn left right left right. Now turn direction 1 we have is clockwise direction, and -1 is counterclockwise direction. So it will basically rotate clockwise and anti-clockwise 4 times, and then it will start turning forward. Now this while count of 2 and all of this stuff we have created to actually verify the whether our robot whenever it has calibrated, so it should follow the respected lines. So we are just checking the sensors 5, that is the rightmost sensor, and the sensor 0, that is the leftmost sensor, to uh, place our robot on line. Now this is a turn L. Basically we use this to turn our robot left. Now we will just see it further. Now motor speeds we have initialized to 0, and the buzzers. So this one we have created because to donate that Zumo is finished calibrating. The first one we played before the calibration of Zumo, and now the after Zumo's calibration, and respectively the LED will turn on. So basically setup was all about turning on the buzzer, calibrating the robot left right, and then whether checking that it has been on the right line, for I mean forward. And after that we have just turn off the LED and turn off the buzzer sound. Okay, so now in the while loop, actually what we are doing, we are calling the function solve maze of dash. If we'll go into the solve maze functions, so down below here is the solve maze function. Now in solve maze function we have created another loop while of 1, and in which we have created follow segment. So what follow segment says to us, In follow segment, we have initialized all our 6 sensors. We have variables offset from center or power difference. Now in another while loop, basically we position the reflectance sensors will read the line from the sensors and it will store in data position. Now offset will check whether how many uh, which to which degree our sensors are from the center of the line, and the power difference is actually a value that compute the motor difference between two motor settings. So if M1 motor 1 and motor 2, if we subtract these two motors, if it is a positive number, the robot will turn to the left. So basically this is a power difference. When the respective value is greater than 0, less than 0, we will decide whether the motor is turning left, right, or whether the shaft is turned or the shaft is not turned. This is a check state we have created to check our motor speed and at different angles. After that, we have done with it. Then we will read our sensors, that what the sensors are reading. So if the above line sensor 0 and all of these sensors it will read. So if there is a straight line ahead, the sensors 0 and 5 will line to be broadened, right? So this is the one loop. The second loop is it is checking the whether the sensors 0, the leftmost sensor and the rightmost sensors detect any line, because when it detect line it will give it 1. So if it has found an intersection it will just return to the loop. Now these lines, now what these lines are giving, that we were actually using the inner 4 sensors 1 2 3 4 here, determining whether there is a straight line ahead, and the sensors 0 and 5 are detecting lines going to the left and right. So for this condition we have created an if and while conditions. Now if we just in the solve maze function we have called the follow line segment, because in the follow line segment we actually make our robot to remain in the line using we also check the sensors 0 and 5. After that, what we have done, that we have created 3 variables of character, and we turn into 0. Now what we now why we are doing, then whenever we have to turn left, we will make this character found left 1, and by that we actually note that that there is a character 1 and we will choose to turn left. Similarly for the straight and right. Now how we are doing it, we are again initializing our sensors and we are reading data from the sensors. Now if the above line sensors of 0, if the sensors if the sensor 0, meaning the left sensor has given a value, or if there are any exits, the our found left integer would be graded 1, or if the rightmost sensors is above the line, so it will just found right is equal to 1. After that it will just give the motor a specific speed, and now this one delay we have to give because it takes a lot of time for the sumo robot to be on the line. So in that instance we have just created a delay. Then again we are checking that whether it has taken a right or left exits or not. I mean we like by checking again and again in order to sustain our results. So for 3 times, and after that at the last we will just read that if the sensors 1 2 3 and 4. Now if now for the straight, to move straight, we have actually the 4 sensors should be turned on, and for turning left the 0 sensor should be turned on, and for turning right the 5 sensor, the rightmost sensor should be turned on. Now for the right, we actually check that whether if any one of the 4 sensors is on, so it will actually be turning in the straight, because when we are going straight, not all of the phone sensors are the same line, so we have just created here or, because anyone if is on the straight line, then it is moving straight. And here we are using a condition if all of the sensors 1 2 3 4, if all of the center sensors are on the line, so meaning not one of them, all of them. So it will just stop there, and the motor speed will be 0, and it will just break from this loop. And we have created, after that we have created an unsigned character dir select turn. Now whatever the turns we will decide on the basis of these conditions, that data will be transferred here in the form of argument, and that argument we will transfer to the turn dir. Now that turn dir was actually here, that we actually see turn left. So here, now here we have called dir in the switch statements. The dir will be left, or then the left case will be called, and it will turn right. Now case p and case l are basically both same, just the left degree, left rotate one full 180 degree, and the d also, but in the left, when there is some line in front of it, it will just go straight, and in b it will turn 180 degree and then on the line. And first thing we have for turning left, we have give the motor speeds, left negative, right positive. And that's when we are just checking that whether the sensor is above line. And after that, then we have just created a case right, and for example turn right, and we have given a specific speed. Now this count is checking that whether our sensor is on the line or not after the turning. Well, it has following the straight path. And if the nothing is else happening, not neither the our zero sensor is turned on, nor our fifth sensor is turned on, our Wemo robot will go forward, and it will just case S will be called. So that was, now here we will see the how different functions are being called, and motor is running left or right. That was it. And basically that simplify path we functions call, because whenever we use only this, because in this turn, whenever our robot is gone there when there is no black line, so it just rotate 180 degrees. So for that we have to simplify, call our function simplify path, and it checks whether the path length is less than 3 or negative b, so it will return again and again. We have initialized different angles, and now switch path length minus I case r. For the right sensor it will turn 90 degrees, for the left 270 clockwise, and 180 degrees. So in different conditions it is rotating at different angles. At the last we created a total sum of the modulus of the angles, and now that modulus of the angle we use at the switch conditions. And so these conditions, if the condition is in this criteria, it will just call the function s. If it is 90 degree, it will call the function right 188, because at b point rotates 180 degrees whenever there is no sensors in front of it, and at right we actually make a turn of 90 degree, and at straight there is no degree turn, and at 270 because whenever we have to turn left, then we will turn 270 degrees. And after that we initialize the path length to -2, because we have just initialized our path length to +2. This one we have right here as 3, because our loop was turning 3 times, so I equal less than 3. That was a simple code. Now if you can just run the code schematic, now we'll see how it is actually working. Now if you can just see the codes, and now here we turn only SD cards, and now we'll run these simulations. Now we have access granted, because our card is inside the pocket. We will run it, and the robot will start first of all calibrate itself 4 times, then it will straight forward, and the path is being stored in SD card. So whenever there is no sensor in front of it, it will turn 180 degrees, and then it will find the black line and start, and it will just follow that path. After that, it will turn 180 degrees. Now we made a condition that it will turn straight if any one of the 4 sensors is on black line. So if any one of the 1, 2, 3, 4 is on the black line, it will turn straight. And for the right, it will turn 270 degrees. For the left, it will turn 90 degrees. That's why whenever the robot is here, it will turn 90 degrees. Now it will also turn 90 degrees. And if any one of the 1, 2, 3, 4 is 1, it will go straight. Now here is the 5th sensor is on black line, so just turn right. Now again 5th, turn right. Now here 0 is 1, it will turn left. So that's how the robot works, and it will follow all the paths. Now at the end we will see that what path we have obtained. So now our robot has reached our final destination or not. For that purpose I created a text file. Now this file is asking me to reload the changes that data has been stored. So I've got my data. Now this is how our robot moved forward, and after that it turned left, then again forward, then again left, then forward, and similarly it turned right, and an end path is just shown here. So this was our tasks here, forward and left. So we were asked to save data on the SD card and to learn about the changes in how a Zoomer robot works. So that was it.